Okay, so thank you very much for coming and welcome to our IFIS seminar this week. We have Taha Yasseri with us. Okay, so Taha is a physicist turned into sociologist. Okay, he got his PhD from Göttingen in the theory of physics of complex systems. Okay, and then he moved to Oxford and also the Alan Turing Institute as a postdoc, research positions. And finally, he got full professorships where he's now in the Trinity College, Dublin in Ireland. Okay. So his research interest, or he has, let's say, contributed mostly to the to try to understand biases in Wikipedia. Also, you're expert in conspiracy theories, okay, and also about bots. And actually, the topic of this is, he will give a course within these socio physics meetings that we have every Tuesday. Okay, so next month he will give a short course on hybrid collective intelligence of humans and machines, which I think is quite a hot topic. Okay, if you want to become collectively intelligent. Okay, he's now on sabbatical. Okay, so he started a couple of weeks here at the IFIX. So thank you for coming. Okay, and he will stay with us until the end of November. Okay, so if anyone is interested in discussing with him, just let me know or just write an email directly to him. Okay. So
thank you very much. Thank you very much, David, for the introduction, and thanks for having me. Yes, I'm spending this autumn here at IFISC, far away from the rain and the storm in Ireland, enjoying the nice mild weather. Coming to IFISC has been a very long-term dream of me. When I was a PhD student in complex system physics, I got to know, of course, about IFISC and Maxi San Miguel. And I think, sent an email asking if there is a position for me. No reply. I'm still waiting. But finally, I made it here, and I'm very happy and excited to be here. So I will be teaching three courses in November on hybrid intelligence, and that's most of the work that I'm doing at the moment. But today, I'm going to talk a little bit about what we have been doing over the past 10, 15 years, starting with Wikipedia, when actually I was a postdoc, and I ended up working with Max San Miguel. We have one paper together, which I'm very proud of. So I talk a little bit about that work all the way to what is happening on social media today and the announcements that are made by our favorite person, Elon Musk, last week, that he's going to make his own Wikipedia now. So hopefully we get to talk a little bit about that as well. So that was dream number one. The dream number two for me has been always to go here, because a lot of my friends from undergrad ended up here. Do you recognize this place? This is CERN. This is the Center for Nuclear Research in Switzerland, France. It's better. Where the Large Hadron Collider is built, and all these exciting experiments in high energy physics are happening. I didn't really have any modules or courses in high energy physics, but somehow, even though I didn't go there, my life was affected by things that were happening there, my academic life. Because as you perhaps know, CERN was also the place where Berners-Lee invented the protocol for what we call www, or World Wide Web. The reason he invented this protocol was it was very difficult for the physicists working at CERN to find documents and connect to documents which were stored on different computers. So he thought, why not collecting these documents using this HTTP protocol that he invented? And later on, of course, web, or to give the full name, www, became a widespread technology. And it was so exciting back then that a lot of companies thought that it's a huge game changer, and it was a huge game changer. But investment led to the creation of the bubble and then the burst of it towards the end of 1990s. I talk about these things because what is happening at the moment in relation to AI and language models are a little bit reminiscent or reminding of those events happening around 30 years ago, hopefully with a smaller burst that is coming up. But what happened right after early 2000, some of you might remember, Web 2 emerged, and Web 2, the difference between Web 2 and whatever was before it was that in Web 2, people could produce content. Because before that, you would have a web page if you were a library, a university, a government office. Normal citizens didn't really have web pages. If you were a company, a big enough company to be able to afford maintaining a web page. But then weblogs came about and then social media, and you didn't really need to be an engineer to be able to have your own website. And that was revolutionary. Perhaps most of you, I'm looking at you, very young looking, don't even grasp how excited I was when a friend of mine explained what a blog or a weblog is. Every person could just write how was their day. For me, that was like imaginary situation, that because before that, internet was for important people. Anyway, today this doesn't even make sense because you don't perhaps even know what weblog is. That's when we had time to write longer text than 280 characters. And then later we had microblogging platforms, so on and so forth. And TikTok is the most sort of current example of. Among these Web 2 projects was, of course, Wikipedia, which was launched in 2001. And again, I remember we had hot debates among friends. I was an undergrad student. How is that possible? Who writes Wikipedia? We couldn't quite understand that people can write an encyclopedia that is on the internet. Because encyclopedias for us were those heavy books in libraries that, you know, some old white people are writing and we buy and we read. They have all the knowledge, but no, you can write it yourself on the internet. So it was very confusing for us back then, and it's still quite confusing even today when you think about all the difficulties we have, even a small group of us to agree on something, how millions of people can come together and write an encyclopedia together. That is pretty useful. Let's admit that. I remember people used to make fun of Wikipedia. Like if someone said something we didn't like and we wanted to say it's not, what you say is basically bullshit, we say, did you read it on Wikipedia? Today, if you tell someone, did you read it on Wikipedia, we are giving them credit because that means that we believe they didn't ask ChatGPT. So they put the time to actually go to Wikipedia. And I'm sure soon it will change as well about ChatGPT, and that becomes one of the main sources. But how Wikipedia works is still a puzzle because we humans are not very good at collaboration, particularly when it comes to politics, religion, all those topics that we are very passionate about. So the zeroth law of Wikipedia is that in theory it really shouldn't work, but in practice it does work. I argue it's one of the last good places on the internet today, and we all use it, and interestingly, language models use it a lot. But then 2004, Facebook was launched, and 2006, Twitter was launched, and we were very excited about them. It was about the time, well, a few years later, when they became widespread, I was working at a place called the Oxford Internet Institute. And we were so excited because the Arab Spring was happening and democracy was coming to the Middle East. People were using these social media platforms to coordinate and organize their political activities. And I remember people were even proposing that, you know, Mark Zuckerberg should be given the Nobel Peace Prize because he is eventually bringing peace to the Middle East. Again, this sounds like the news from yesterday, just replaced Mark Zuckerberg with someone else's name. But I remember my colleagues were writing books praising social media and how it is a game changer. It was a game changer, to be honest, but the game that was played in a different turf until things came back home. In 2015, the Conservative Party in the UK for the first time used Facebook advertisement for the political campaign. They won the election big time. One of the promises of 2015 election was the referendum for Brexit. In 2016, the referendum happened, and Nigel Farage and his friends use social media to spread misinformation and xenophobic content to pursue people to vote for Brexit. 2016, Donald Trump got elected as well. First time, again, his use of social media was instrumental and quite helpful in his success, one could argue. And we started to think, so the social media is very open and you can put everything you like on it. Excellent. But then you can put anything you like on it, which is a problem because it could be misinformation, it could be conspiracy theories, it could be hate speech, all the things that we don't want to have in our public discourse. And it's not just, for many years I remember people saying that, okay, it's online, the real world is still fine, until the real world was not fine anymore because the conspiracy theories and fake news spreading on social media could affect people's behavior, namely those ones who decided to riot the Capitol in Washington, D.C. 2021, who believed that the previous US election was rigged because they read it on Twitter. So today, we have very mixed feelings about social media. And some of us think that that was a mistake that we shouldn't have really made. And some people still have a little bit of hope. But I think we all agree that there are problems. The issue of polarization, the problem of hate speech, and the issue of misinformation. When you add generative AI to this, we also have the problem of deep fake content that is fabricated completely and how easily it can be spread on social media and misinform people with huge consequences. So let's talk about polarization because ironically last lecture here that I attended last week was also a little bit about polarization and magnetism in a very physics context. But I think that's the topic that we are all a little bit familiar with. When it comes to social polarization, it's simpler. It's not polarization, it's not political polarization, it's not a new thing. It has been existing in our societies for a very long time. Because some people blame social media for dividing us, we've been always divided. Maybe social media are making us more divided, one could argue that, but at the same time, they give us the possibility to look at ourselves. Before having the social media platforms, it was really hard to measure or to quantify or even observe polarization in societies. The only observation we could have was the election, who votes for whom, but that also is the very core of democracy, to have different options and vote for different options. But how separated and divided we are, only first time we started to observe when we look at blogs. That's a very famous image. I think it made it to the cover of Science as well. Those the circles in the network show blogs, those long personal websites people used to write. And the edges are hyperlinks between the blogs. The colors represent the political affiliation of the blog. Red, Republican, blue, Democrat. And you see that there is a huge segregation, separation between colors. And the problem with that is that if you are one of these nodes, red nodes, in the middle of the red bubble, you think everyone is red. You can't even imagine someone thinks differently to you. And the same, if you're in the middle of a blue circle, namely you're a professor in Harvard, everyone around you thinks the same way, and you cannot even imagine someone might have different opinions. And when you're not able to acknowledge other people's existence, then of course hate emerges, then of course other issues emerges. When you spread something within this bubble, no one challenges it because people find it aligned with their own opinion, and that's also a very good opportunity for fake news and misinformation to spread. So the real problem is polarization. This is rather old, not 20 years old. Later on Facebook, people showed the same. And later on Twitter, again here, each circle, each dot is a Twitter account. The edges are the followership on Twitter, and the colors show political affiliation. We see a huge level of polarization. So that is the problem, one of the main problems with social media. And the question for me has been, okay, we say Wikipedia works and it's powerful and it's useful because everyone can edit it, it's open. Yet social media don't quite work because everyone can post something on them and people post weird stuff. So what is it? What is the problem with openness? Is openness good, or is something that we should try to reconsider and try to safeguard or try to gate these online platforms and not let everyone post anything that they want? And that's a question I'm gonna try to address in the next half an hour. The answer, spoiler alert, is I don't know. But we try to sort of move towards an answer and at least have a comparison between the two. Let's start with Wikipedia, and as I said, try to understand how it works. I mentioned that disagreement is very common in groups, among colleagues, among friends, among families, let alone about people who don't know each other and are editing these articles anonymously. Edit wars happen. Sometimes these edit wars become so big that they make it to the news. Often because an external event has happened, like Michael Jackson dies, and people swarm to Wikipedia to write about him and share new facts, but the facts are not established yet. There is a lot of conflict and editorial tension. But sometimes also there are edit wars on topics that are not current affair. To study these edit wars, we had to come up with a simple way, because if you have edited an article, a paper you are working at with your supervisor or few colleagues, you see that after a few iterations, it's impossible to know who has written what. And now imagine thousands of editors are writing about, I don't know, Donald Trump or the country Spain. It's very difficult to follow who has written what. But we were lucky because there is a very specific type of edit that you can commit to a Wikipedia article that is called a revert. That's basically like the undo button on any word processor. They built this undo button in the software to help people control against vandalism, because it was very common back then. People go and delete a whole article or add some rubbish. So they wanted to enable editors to just press undo and make it okay again. But people started using this revert function also in their normal activities against each other. Or sometimes against themselves. I write something, I see a typo, I press undo, and then I write it again. All of these are recorded, and that's amazing because everything that has ever happened on Wikipedia is recorded. Back then, when we downloaded the data in 2010, it was 4 terabytes of data. No, I don't even know what's the size, but it's so big, even though it's mostly text, because all the revisions are recorded. So computationally, you can look at the history of an article. A random example of article in English Wikipedia. If you log in, you can see the history of the article, and if you go to the history, you can see different revisions. Well, I have some examples, 6 from a few years ago, and each text has also a summary, what has happened. Here you see that someone added 184 characters and someone deleted it. Someone else or the same person added it again, deleted, added, deleted, and so on and so forth. People do that a lot. And these are very easy to detect computationally. You just compare different versions. When there are 2 identical versions, you know that a reversion has happened. So we extracted this and built a network because, you know, physicists like networks. Here, this is an example of a network of reverts. Among editors who have edited the article about anarchism, the political ideology, on English Wikipedia, each circle is an editor, and the edges show the reverts between the 2 of them. If they have reverted each other more than once, the edge is thicker and thicker. So you see there is a handful of them who spend a lot of time just reverting one another, and this is only one article on one language. So we extracted around 5 million reverts from the first 10 years of Wikipedia's history in 13 different languages. And we wanted to study this network of reverts because I was at the time a postdoc in Budapest, working with János Kertész, a famous network scientist. And we wanted to see if we can measure this thing. Because not all the reverts have the same weight. If I make a mistake and revert myself back, it's not a conflict. Or if someone comes in and makes a mistake, I revert them, it's not a conflict. But when two experienced editors back and forth are reverting each other, that might mean something. So we came up with a way to quantify this thing, and the first thing you want to do is to look at the most controversial articles. Which articles in each language have experienced the largest amount of conflict. This table shows the top 10 most contested articles in 5 different languages back in 2011, the first 10 years. Back then, George Bush was the most controversial figure in English Wikipedia, followed by anarchism, Mohammed. Back then, we would call it global warming. Today, we call it climate change. And funny enough, part of the discussions there was how to call this thing. And so on and so forth. You see there are some common patterns, like Jesus is everywhere, because we know religion is a controversial topic, but there are also some very specific niche language-specific issues. Like if you look at the Spanish Wikipedia, Club America, Atletico Bilbao, FC Barcelona, Alianza Lima, most of them are football clubs. Well, outside of Spain, I usually make a joke, but I'm not sure if I can make the joke. But some could say, well, it's still religion, right? But a different religion in Spain. But also, you guys know that this is not about football. These football clubs have political connotations and backgrounds that makes them controversial objects. In Czech, for example, you see a lot of articles in the top 10 are about sexuality and gender and issues related to gender and sex identities. And again, thinking about contemporary Czech Republic, where Czech language is spoken mostly, this doesn't surprise you, the transition between a more conservative Eastern Bloc country to a more modern, open country. Anyway, each of these articles who've made it to the top 10 have their own story. And some of the stories I know, for example, in German Wikipedia, the most controversial article is about the country Croatia. And we couldn't understand that, like, why? Then we had to go, and the good thing is that we can read the history, we can read the discussions. It turned out that there are 2 groups of editors in German Wikipedia, the Croatian editors and the Serbian editors, who are not challenged in their own language Wikipedias, because, well, of course, they're correct among the speakers of their own language. But they found German Wikipedia as a common battlefield, and the German is good enough to edit articles, and then there they have edit wars in relation to Balkan wars and issues in Serbo-Croatian war. Anyway, I'm not gonna go through all these examples. As I said, many of them I still don't know why they are so controversial, but some of them we understand. As physicists, or back then, as physicists and now as ex-physicists, we were interested in the dynamics of these edit wars. So that measure that we came up with, which helped us to identify these lists, is a measure of conflict that grows in time, because the article at the beginning has no history. So let's call that M, the quantity that we came up, is 0. But over time, it increases. Here I have 3 examples how the measure of controversy can change. The x-axis is just number of edits, because edits could be non-controversial, they could be normal. But then some edits contribute to the value of controversy, the M score. And this is the example of bombing of Dresden at the end of the Second World War, a very controversial event, because many people say it was a war crime, let's say it. But it's something that has happened in the past. There is no new evidence about it. So what happens is that people are writing about it rather peacefully, then at some point conflict emerges, and then they eventually settle and they get into consensus. And then the article lives its normal life. There are topics like anarchism that are very hot and they never experience any consensus. It's like a never-ending edit war. And then there are articles like Japan that we have peaceful editing, edit war, peace, edit war, and so on and so forth. And you can imagine, because every now and then something happens or new events emerge and people want to write about it, and that might ignite a current edit war or one of the older ones. So all these different scenarios could happen, and we wanted to model it. we came up with an agent-based model, which is very much, yeah? M is the measure of controversy, which is, simply put, the volume of this network for each article and how it changes over time. Remember, this network are the reverts. So the more people revert each other, M grows faster. But it's not exactly a count, a simple count, because we gave different reverts different weights depending on who is at each end of it. If David and I start fighting as, let's say, experienced researchers, it's a bigger signal of conflict than when two PhD students are fighting. Let's put it that way. So we gave different weights to the interactions, put everything together. It's a long formula. We came up with measure of controversy. That is a quantity that changes in time. It only grows because more and more reverts coming in, it can grow. Yeah. So now we want to simulate, we want to understand the dynamics of this quantity. We did an agent-based modeling, which those of you who do computational physics must be very familiar with it. It's just a simulation. We have n editors. Each editor has an opinion, which is a number between 0 and 1. And two agents interact with one another. They might have different opinions, xi and xj. And after interaction, they sort of get a bit closer to one another. They update their opinions towards the center. They don't need to get to the center. This parameter mu could be any number, but if it's 0.5, that means they get into the middle point. Well, that's very intuitive. You meet someone, you talk, and you get closer to one another. But if you meet someone and they think very differently to you, they are outside of your confidence, you don't even engage with them. You just leave, no update in the opinions. Okay? This was a model introduced by some French people in 2000. We just borrowed it and well, let me explain what happens if you run this simulation. You start with a uniform distribution of opinion X, and if the tolerance level epsilon is large enough, people eventually get to consensus. And there is no reason not to have symmetry. So everyone's opinion, all the x's will be 0.5 if you wait long enough. But if epsilon is small, people are not very tolerant, then what happens is that fragmentation happens. Two groups emerge, and these two groups are stable because the distance between the two is larger than epsilon. That means that there is no chance for them to ever get close to one another. This is a fully polarized society, and there is no hope. So the model is rather simple because the outcome of it can only be full consensus or full fragmentation. But this is not a good model for Wikipedia, because on Wikipedia, it's not only people interacting with one another. In fact, people rarely interact directly. They always interact with the article. So we have to introduce this new agent that we call article, and it has an opinion, A, which is also a number between 0 and 1. Each agent interacts with the article as the following. I'm here, xi. I read the article and it's here. I think it's too wrong. It's outside of my tolerance. So I pull the article's opinion towards myself. Okay? xi remains the same after interaction. A gets updated towards xi. But when I read the article and the article is within my tolerance, it's good enough, then I don't touch it because it takes energy and time to edit an article. But by reading the article, my opinion becomes closer, goes closer to A. I update my own opinion. I get influenced by what I just read. Okay, it's a very simple minimalistic addition to the model. Now what we do is that we run the original model and we tune the parameters so we get 3 segregated groups. And then we turn on the article. We let them interact with the article as well. And we see that depending on the parameters, we get to a consensus. Even here, that looks like consensus never emerges. If you wait long enough, eventually it gets to consensus. So the lighter blue is where the editors, the agents are, and the dark blue is where the article is. So, okay, consensus could emerge among people who would not be talking to one another anymore as soon as you ask them to interact with the article. And that's the sort of long-term interaction that people also have seen in polymer alignment. But again, as physicists, you might be interested to know that here in the original model, because of the symmetry, the consensus opinion is always in the middle, or when we have fragmentation, it's symmetric. But in this new model, the symmetry breaks. The consensus could be anywhere. Even though we started from a symmetric distribution, the consensus could be here or could be here, depending on each time you run the model. Which has a very interesting consequence. That means that, okay, people might agree to a consensus of Wikipedia, but that consensus is not necessarily the average of everyone's opinion. It's not representative of all the ideas or all the opinions. And that is very true anecdotally if you have some experience of editing Wikipedia. Consensus does not mean democracy, and Wikipedia is not about democratic representation of all opinions. But then what about cases like anarchism, when the edit war never ends? To replicate that feature, we added another mechanism, and that's agent renewal, because the editors of Wikipedia are not constant. New editors come and old editors leave. Particularly if there is an external event, a lot of new editors come in. So we replace agents at a constant rate of p, and the new agents come with a fresh idea, a new randomly drawn number between 0 and 1. When we add this to the model, we can replicate those curves I showed you earlier, the evolution of conflict. These are from the real data from Wikipedia, and these are our models. So we can tune the parameters to replicate what we have observed in the data. And now you have a functioning model. You can change the parameters. There is a phase transition, and I regret so much, for some reason I don't have the diagram. This is the only audience who actually know what phase transition is, and I don't have the diagram. But you can see there is a phase transition between peaceful editing and edit wars, and people can move back and forth between these two phases if you increase the size of the system, if you increase the rate of agent renewal, or if you decrease people's tolerance. All intuitively makes sense, but the policy recommendation is that if you want to stop an edit war, just decrease the size of editors. And people in Wikipedia do that. They freeze the article. They don't let new editors edit the article if they see conflict is emerging. Okay, what we learned from all of this: lesson 1, collaboration encourages consensus. And it sounds like a motto you might get tattooed on your arm, but this is a mathematical observation, because remember, those groups who were not even talking to one another in our model anymore, when you ask them to interact through the article, there is a chance for them to get to a consensus. So sometimes talking would not help you to get close to someone, but if you do something together, it might help to get closer. Then we have another article, again, bunch of physicists. We use the same model, and we introduced a new type of agents, the agents that are stubborn and have extreme opinions, like zeros and ones, and they don't easily change their opinions, the troublemakers. We thought, let's see what happens when we add them. Surprise, surprise, having them is very useful. Because when we ban them, like when we punish them and stop them, freeze them from changing the articles, the consensus emerges much later. And then, again, it's easy for you to understand that it's a little bit like they shake the system and help the system find the local minima. Whereas without them, it might take much longer for the system to find that consensus point. Again, the consensus is not a good thing necessarily, because we don't know where is the position of it, but consensus happens faster when these troublemakers are in the system. And you might think I say that because I read the news, but this is exactly what's happening now in all the wars that Donald Trump decides to declare peace about them, that a new person comes in, shakes the systems, he has his own opinions, quite extreme perhaps, but consensus or something happens quickly. How stable it is and how democratic it is a whole different question. So we show that mathematically and using simulation back then within the same model framework that I explained. Finally, so what we learn here is that banning editors with extreme opinions postpones the consensus building. Also, we looked at the quality of the articles, because for a period of 1 year, you could rate the quality of articles you see on Wikipedia on different dimensions. And we took those numbers and we looked at how those numbers differ depending on the experience that the article had, how much conflict they experienced. And we see that the quality is at best if there is a bit of controversy. It goes down when you end with edit var, or if it's peacefully written. But when there is a moderate amount of conflict, the article's quality improves. And that also makes sense because the article gets polished, different ideas are represented, all together it becomes a better product. So if no one challenges you on your article, your papers you're working on, perhaps it's not going to be a very good paper. But if there is a moderate amount of challenge and back and forth and reviewer number 2 forcing you to do things, it's useful. So lesson 3, certain amount of conflict increases the quality of the articles. The readers would rate the quality of the articles. We have this data for 1 year, and then they removed the system. I don't know why, but the data was available, and so that's independent from our measurements. Okay, now let's talk about social media. I showed you these diagrams, and I talked about polarization. Let's model this, and in the next 3-4 minutes, I'm going to present a paper that has 0 images in it. It's a mathematical paper published in Journal of Mathematical Sociology. It's all math, no data, no nothing. But what we tried was to come up with a simple mathematical model to understand polarization in social media. The model is very simple. Imagine we have 2 colors and the colors are not connected. They connect to one another. And there is a slight preference for each node to connect to the node that has the same color. The colors represent political opinion. I make friends at a new party. I'm more likely to make friends with people whose opinion is a bit closer to mine. You run the formula in 3 lines. You can show that if you wait a bit, you get full polarization. That preference for like-minded people eventually leads to segregation. And that is known. That is very much Schelling's model. You might know of him and his model on a network. But then what if people also have the chance to connect to friends of friends who are not necessarily like-minded? That is known in the literature as the strength of weak ties. People that are not very close to me, but they have fresh ideas and fresh information. It's been shown that people are very likely to find their jobs through those connections rather than their close friends. So we add that to the model, the math gets a bit longer, the result is the same. Doesn't matter how much connection to the weak ties, how much emphasis you put on the weak ties, because of that homophily, because of that interest in the same color, you always get segregation and polarization. Okay, at the time when we were writing this paper, people were suggesting it's up to Facebook and Twitter and social media to break the bubble. On Facebook, instead of showing what my friends have posted, it has to show me things that people of the different party or opposite party have posted to challenge me and to show me different content. We introduced that in the model, so a positive algorithmic bias, an algorithm that shows me things that are different to me and encourages me to connect to people of different opinions. The math gets a bit longer, but the result is that to break the bubble, you need infinite amount of intervention, which is not realistic. So there is no way to break the bubble, even if you use the algorithms. And the reason is that at the very beginning, when we set up the model, we allowed people to reconnect. And we still have that tendency, even though the tendency to connect to like-minded people can be very small, but as long as it's not 0, you always end up in a bubble. So what does it all mean? That means that if there is no cost, no friction against rewiring, unfollowing someone you like better, you always end up in bubbles. The reason that before the internet, we had polarization, but things were not that extreme, is that, okay, just because your neighbor is a racist or I don't know, someone with a different opinion, you don't move that easily because there is a cost against moving houses or neighborhoods or countries. Some of us do, but not all of us. But on social media, it's so easy. You just click unfollow, block. Actually, if you report something on social media as offensive or non-kosher, immediately the platform asks you, do you want to block the person? Do you want to report the person? Do you want to put an end to this friendship? Which is not very realistic. You know, if I was doing the same thing, I would not be talking to half of my family for my entire life. You know, we all have that racist uncle. So in real life, we maintain our connections despite disagreement. But on social media, we are encouraged to cut the connections, and this process is accelerated. Why platforms want us to cut these connections? Because they want to feel good and supported and happy and spend more time and click on more ads, and they make more money, which is fair enough, but it's not helpful if you want to break the bubbles.
Say the platform want to cut the connection, but do you really want to cut the connection, or they just allow you to do it and you can do whatever you feel happy and you can?
The second, not only they don't.
Say no penalty for cutting connection.
Exactly.
If you were giving a penalty because you cut connections, probably, which is what happens in real life.
Yeah, exactly. That's the point. They don't penalize you. And depending on the design, on different platforms, you are also sometimes encouraged. You know, when they see there is a tension, they encourage you to consider blocking people, because that's an easier solution rather than you making a complaint again and again. Okay, you just actually said what I was going to say. As long as unfollowing remains costless, frictionless, echo chambers form. That's message number 4. So what is the solution then? One solution is, of course, to shut down everything. One other solution is to introduce a cost, try people to encourage people to talk and engage rather than just unfollow each other. Those are different solutions. One solution that we have been thinking for several years was learning from Wikipedia example, because on Wikipedia, you cannot avoid someone. You have to work together if you want the article to be there. You cannot just say, I'm not even talking to you. Don't touch my article. No, there is one article you have to make do with anyone with any different opinion. How about we take some lessons from Wikipedia and apply it to social media? We've been thinking about this with also, I think, computer scientist, physicist, Philip Menser from Indiana, and we were writing this piece suggesting that some things could be done if we use crowdsourcing and community solutions to rescue social media. As we were working on this paper, a big announcement was made by back then called Twitter, now X, that they introduced a new project called Birdwatch. And in Birdwatch, they are relying on the community of users to combat misinformation. How Birdwatch works, Elon Musk not only changed the name of Twitter to X, but also changed the name of Birdwatch to Community Notes. Has anyone heard of Community Notes or Birdwatch? Few of you. So what happens? There is a tweet, there is a tweet, you think it's misleading as a user, as a birdwatcher, you can write a note to give context to it. Different people can write different notes, and you can also rate on each other's notes. The best note will appear next to the tweet on Twitter. Everyone can see it. If you're still on Twitter, sorry for you, but you can see these notes all over. And Elon Musk is so excited when someone writes a note on his tweet, and even though debunk it or contextualize it, but he somehow thinks that's democracy, you know. I allow it. I didn't kill the person yet. So this is happening at the moment. Initially, it was only in the US, but now it's deployed internationally. And earlier this year, also Mark Zuckerberg announced that they stopped doing content moderation. They used to pay companies to look at the content. They are not doing that anymore. but they are building this new platform very much like community nodes to control the content on Facebook and Instagram and WhatsApp, all the Meta products. So that sounded promising because, as I said, I was rooting for these sort of solutions, the community-based solutions to combat misinformation. So after a few months, when Birdwatch was launched, I collected the data. It's a tiny data because it was very early on. There were about 6,000 notes. Notes are this text that people write to debunk, written on around 2,000 tweets by around 3,000 birdwatchers, and they had voted on each other's notes 36,000 times. You can build a network in which the two nodes are birdwatch users, and the connection is that how they voted on each other's notes in the past. What I'm going to show you is just a network showing the agreements, the upvotes, because let's say there is a tweet, David thinks it's misleading, he writes his note, I can say I agree, or I can say no, I disagree with note, the tweet is fine. When you look only at positive interactions, and this is the network you built. Each node here is a birdwatch user, connections are agreements, and the colors are standard community detection algorithms based on the only structure of the network. We did not look into political affiliation of anyone, but as we can guess, perhaps one of these bubbles are the Republicans, the other ones are Democrats. So failure, because that's very much is like the original problem. So among birdwatch users, the ones who are supposed to make the platform better, most of their activities are very much driven and determined by their political interests. So people cannot really be objective. So sounds like a failure, but then when you think a bit more about it, this is not exactly Wikipedia. On Wikipedia, it's not that you write an article and then I vote on it. We have to write together. And our simulation showed that that interaction is important. So we thought we can run an experiment. We built a replica of community nodes / birdwatch. We recruited people. We gave them some misinformation. They had to write about it, but they also could chat with a partner, and they had to agree on a note and then submit it to us. So basically, that's the design of the experiment. We pair people differently depending on their political affiliations. In one group, we let them know who is who, like your partner is blue or red. In one other group, we don't even let them know. And then they have to work together and write something together. We have all different combinations of political permutations. And what we learn is that, yes, people who write the notes in groups, regardless of the details, write better notes than the ones who are written individually. Who says a note is better? We crowdsource it. We asked a large number of other users to say if this note is well written or not, and we separated them based on their own political affiliation. We see that both Republicans and Democrats agree that the notes that are written collaboratively are better. The increase is even bigger when Republicans are evaluating. That suggests that notes that are solely written by Democrats are not necessarily good notes, but they can benefit from having more diversity in the group. And then also we asked the group of experts who were not partisan, who were not subjective, and they also said the group's notes are better than individuals. So that doesn't surprise much because two brains are always better than one. But the fear here is that if you put a Republican and a Democrat to work together, they might not do anything together meaningful. But it turned out, no, they can work together, at least in this context. But then, now let's focus only on the expert raters. When we look at the combination of the notes, the team, sorry, this is a mixed team writing a note on a tweet that was Republican. We see that when they are debunking Republican content, the diversity is good. The mixed team writes the best notes. But if you are debunking Democrats' tweets, the Republican team without diversity does a better job. So we always say diversity is good. The more different people in the team, the outcome better, but it's not as straightforward. At least in this case, we see that depending on the task, what they are trying to debunk, diversity might not be necessarily the best solution. This is a pretty much ongoing work. So let me just conclude by saying that community-based solutions can work if implemented correctly. So not just by voting on each other's contribution, but engaging directly. And diversity works also, but in mysterious ways. We are running some experiments that we hook up people with ChatGPT, and instead of two humans working, we have a human and AI trying to work together. This is very much work in progress, but we see that you can improve the quality of content, but only if you ask ChatGPT to give certain feedback to people. If you have a ChatGPT that argues with people, it's not people don't engage with it. But if we prompt engineer ChatGPT to be supportive, yet trying to balance the political affiliation of the person, it can work. So I'm going to jump to a conclusion here that language models can help improve the quality of fact-checking notes. However, it's complicated. Okay, what did we learn? Collaboration encourages consensus. We learned that from Wikipedia simulations and observations. Banning the extreme ideas is not necessarily a good decision. Certain amount of conflict could be useful. And as long as you let people unfollow each other costlessly, you will end up in echo chambers and bubbles. Community node solutions could be useful, but you have to think about the design, and diversity, even though it's important, but it's not always the best option. And finally, language models are gonna be useful, even though we make fun of them at the moment. Thank you very much.
Thank you, Taha. Very interesting. So, questions? There were already a couple of questions, but just a moment.
Yeah, I have a question about one of these messages, the second one, that says banning editors with extreme opinions postpones consensus, right? So I wanted you to explain a little bit why is this happening, no? Because it seems counterintuitive, no?
Yeah. So you remember this is a result of a simulation, and in the simulation we had these locked situations where the two groups were have emerged, but the distance between them was too big for them to meaningfully interact. So what happens is that these extreme opinions can really shake this and pull the system out of this locked situation, because they can pull the groups left and right, and through that earthquake, you can create the chance of the two groups meeting each other somewhere and then merging together. That puts it in a very sort of intuitive way.
Okay.
So they insert energy to the system to jump out of the local equilibrium and find a better equilibrium. I assume you are a physicist just because you have glasses, but I might be wrong.
More questions or comments, remarks?
Yeah. Wanted to ask regarding this bird watching. So it seems like when a bunch of users, someone writes a note and the others just vote for it, it seems like there is some asymmetry of effort that you take to change it. So maybe that would also happen if there would be some, for example, one would write a big note and then the others were allowed only to make small comments. Maybe that would be somewhere in the middle between these two extreme cases.
Yeah, I understand what you say. That's very interesting. Yes, the asymmetry of effort. So because someone does the job and the other person just says good or not, it's a little bit like how you write a research paper with your supervisor. It's very easy for them to go and write it again, or they might get involved and start also getting their hands dirty with overleaf. I understand your point, and sort of to test this, one could design an experiment in which the second person does not equally contribute, does not vote, but like you can give some feedback. That's very much what we are doing with LLM at the moment. But yeah, we should have had the control group where a human gives little feedback. Yeah, thanks for that.
Also, another small comment, at least the first part, in the first part of the talk, I immediately remembered the same methods, but in a bit different context. So people that do the social insect research, for example, for ants, are using almost exactly the same models. For example, when ants are carrying food to the nest and new ants come in to bring new information, much like these extremists come and introduce noise to the system.
That's very interesting. Thanks. Yes. Thank you.
Very inspiring talk. Have you studied how the system size influences the results? I imagine that in Twitter or Facebook, there are many orders of magnitude more editors or people than editors in Wikipedia, I guess. And this seems to me that this makes transitions sharper in large social media than in smaller ones. Is this true? Have you studied this? Or?
No, that's true. And again, I even have the diagram somewhere in the cloud and on this laptop. That you're absolutely right. Well, it's not only a scaling. Actually, it is a nonlinear scaling, and the size itself can push the system from one to another one if you multiply it by the rate of renewal. So the number of new people matters, not only the rate of them. So you're absolutely right. And in Wikipedia, we might have millions of users, but it's not that all of them at the same time are working together. They are separated in different areas. The same on Twitter as well, but that is one of the differences for sure, that the size matters. When I give this talk to social scientists, they immediately say that the business model of the two is very different. And that's true as well. You are on Wikipedia anonymously contributing to the human knowledge. For most users, that's true. On Twitter, you have personal incentives, political incentives. It's your job, you know. And Twitter X is a business product. Wikipedia is a non-for-profit product. It's a social good. So there are lots of differences, including the size, as you noted. Yet, you know, as physicists, we want to look at the fundamental similarities. And when you look at the question of openness, the problem, as we see, is not really about the openness. It's about the design. It's about the size. It's about the pool of the type of people who are in these models, and so on and so forth. But yes, the size matters.
Thank you very much. I would like to ask something, maybe it's well, a detail, but it has to do with the model for the Wikipedia. If you could go to the slides where you give, for example, the probability of renewal or maybe earlier. I find very interesting both the model and also the figure, the different kind of figures that you can find for example, the bombing of Dresden, etc. And my question is, you said that you need, for example, this probability of renewal to be introduced in order to not always find consensus, right?
Yeah.
But my question is that would that be the mechanism also for the graphs that we see, for example, about anarchism, where there is no consensus? Because when you introduced these graphs, you said that the difference between Japan or Dresden and anarchism is that, for example, the bombing of Dresden is something that happened in the past. At some point, there was a war, a consensus was found, and then nobody really cared on changing this. But anarchism is something that really always drives people. But I couldn't associate that with the probability of renewal. I think that the same people can fight about anarchism over and over again. Doesn't have to do with the renewal. So my question is something that you can check, because, for example, you know who made the change in the Wikipedia page, so you can measure the probability of renewal.
Yeah.
So
yes, very good. And I found the time I hope it works, yes, to find the papers we wrote with Maxip. And that's the diagram that for some reason I had removed from the slides, because it's exactly what you were saying. So we have two important parameters, the tolerance and the size multiplied by the renewal rate. And here we have tolerance is small. So here we have var, forget about the inset. And here we have peace. And here we have eternal peace when the tolerance is too big. But you see that one way of going from peace to var is by increasing n times renewal. That is one mechanism. The other mechanism is for a fixed size and fixed renewal, or even no renewal, going from here to here by decreasing tolerance. So I think the case of anarchism, it's not necessarily a huge pool of editors. It's just people are very sensitive. One of the examples I had on the list was the list of professional wrestlers in the top 10 in English. And we were like, why people are so carried away? And then you read and you see that, oh, these people are obsessed with how to refer to these wrestling champions, like the nicknames. It's a controversial topic. And these people are really into fighting. They love wrestling and fighting. So they don't have a very large epsilon. So you can go from peace to war in different ways, depending on the size, renewal rate, or tolerance. Sometimes an article becomes controversial because something happens and all of a sudden people care differently and epsilon changes. How many of us cared about Palestine and Israel conflict 5 years ago, and how many of us now have very strong opinions? So that means that our epsilon at the individual level can shift. In our model, we use the same value for all the agents. Again, mean field physicist type of thing, but there is a diversity also in the group. Some people are more tolerant, some people are less. But you're all right.
Any other contribution from the audience? Okay, so remember that I will be around until the end of November. Okay, so feel free to discuss with him, and thank you again.
Thank you very much. Before you clap, sorry, just 1 minute about the group. So we are not, towards the end of the seminar, I showed you some experiments. So we are doing a lot of experiments now at the moment where people are interacting with machines, real AI. Sometimes we lie to them. They think they are interacting with AI, and so on and so forth. And we are running all these behavioral experiments to observe how people's behavior changes. This is the end of the lecture. The lecture starts by talking about wisdom of the crowd, collective intelligence among humans, a bit of literature, and then hopefully we finish by showing some of these experiments that we are doing. So I never taught this lecture before, so it's going to be quite experimental as well as being about experiments. Thank you very much.
Thank you.
Hey.